Recursion. Right. Recursion is a programming technique in which a method calls itself. And the process we're going to use to demonstrate that is the triangular series. A triangular series is a series that starts at 1 and the nth term is found by adding n to the previous term. So, to illustrate that, we're going to draw a single circle to indicate that the first term is 1. Then, the series says the nth term is found by adding n to the previous term. That means to find the second term, we're going to add 2 to the previous term. What's 1 plus 2? 3. Then, to find the third term, we're going to add 3 to the previous term. What's 3 plus 3? 6. Then, to find the fourth term, we're going to add 4 to the previous term. What's 6 plus 4? 10. Then, to find the fifth term, we're going to add 5 to the previous term. What's 10 plus 5? 15. Right? Now, here's how this process would look in code. You have your prop method called triangle, receives a single parameter called n. We start our total at 0. Then using a while loop, we add 5, then 4, then 3, then 2, then 1 to the total. Of course, by decreasing n by 1 each time until it reaches 0. After we add everything up, we return the total to get our answer. This kind of approach, we call it the iterative approach. We call it that because we're repeatedly executing the same instructions. Anytime you're executing the same instructions over and over again, you're using an iterative approach. All right, now let's discuss the recursive approach. What the recursive approach will do is it'll divide this process into two parts. It'll say that the fifth term is equal to 5 plus the fourth term. Now, what is the fourth term? The method doesn't know, right? We haven't gone that far yet. All we've done so far is ask what is the fifth term in the series, and we've answered it by saying it is 5 plus the fourth term. Well, what is the fourth term? The fourth term is 4 plus the third term. All right, well, what's the third term? Well, the third term is 3 plus the second term. Okay, well then now what's the second term? Well, the second term is 2 plus the first term. And then what's the first term? Well, the first term is 1. We know this because this was given to us in the definition of a triangular series. We were told in the definition that 1 is the first term. So for this first term, we don't have to guess. We don't have to do any math. So now that we've reached the bottom, we can start working our way back up. 1 plus 2 gives us 3. 3 plus 3 gives us 6. 6 plus 4 gives us 10. 10 plus 5 gives us 15 for our final answer. All right, now let's take a look at the code for this process. The recursive approach to writing this program, once again, we create a method called triangle that receives a single parameter. Then we say if that parameter is less than or equal to 1, then return the value 1. Otherwise, return n plus triangle n minus 1, which is our recursive call. All right. Now, let's analyze this method a little more in depth. There's 2 parts to this method. In fact, there's 2 parts to every recursive method. And that is, first, each recursive method must have the recursive call. That's the obvious part. It can't be a recursive method without there being a recursive call. And in this case, that is triangle n minus 1. Now, what you should also notice about the recursive call is that the input decreases. We give it n minus 1. This is a requirement for any recursive call. You cannot put n plus 1 or n plus 2 or n times 2. You cannot increase the input. You must decrease it, whether you put n minus 1 or n minus 2 or n divided by 2. Regardless of what you put, you must decrease the input every time. Which brings us to the second part. Every recursive method must have a base case, and that is the case where the method stops making recursive calls and returns the value. Without a base case, your recursive method would simply call itself forever and ever and ever until the computer eventually runs out of memory. So, when writing your recursive methods, never forget to give yourself a base case.